Hi, my name is Erin and I study greenhouse gases at the University of Alberta. So a greenhouse gas is a gas in the atmosphere, so it's a molecule, which is a combination of atoms. And these atoms, these molecules, are capable of storing energy as heat, okay? So greenhouse gases are capable of storing that heat energy and redirecting that heat back to Earth, causing a warming effect, okay? So the major greenhouse gases are carbon dioxide, which is also called CO2, nitrous oxide, which is also called N2O, and methane, which you can also abbreviate as CH4. So when we talk about these three greenhouse gases, sometimes it's easier to talk about them all as one, and we put them all in terms of carbon dioxide. Well, how do we compare carbon dioxide to methane to nitrous oxide? We have to put them all in the same scale. So we have to make them comparable somehow. The difficulty comes in the fact that carbon dioxide, methane, and nitrous oxide, they're all different compounds, and they all have different abilities to trap heat. So carbon dioxide has a certain ability to trap heat in its bonds, nitrous oxide has a different capability, and methane has a different capability. So we have to figure out how they compare to one another, and it turns out we did it. So we figured out that nitrous oxide is capable of holding approximately 273 times more heat energy than carbon dioxide on a mass basis. So this means that the same amount of nitrous oxide compared with the same amount of carbon dioxide, this nitrous oxide would be able to hold heat energy 273 times better than carbon dioxide. Okay, so to combine or to compare the two, we convert nitrous oxide into what we call carbon dioxide equivalents. So we convert that nitrous oxide by multiplying it by 273 and then adding it to how much carbon dioxide is released. With methane, methane is similar. So methane actually is capable of heat holding or holding heat in its bonds about 25 times better than carbon dioxide. So to convert methane into a carbon dioxide equivalent, we multiply the amount of methane by 25, and then we add them all together, the amount of nitrous oxide multiplied by 273, the amount of methane multiplied by 24, the amount of carbon dioxide, and we get one value that we call CO2 equivalents. Okay? And this tells us about the global warming potential of those greenhouse gases. So how much are those gases going to be able to contribute to global warming?